I feel like a decade of maths has led up to this. So we're going to use predicate logic to prove this proposition. It's a tough one, but I think I can do it. So let's define T as Tung Tung Sahur. And we're going to put, obviously, J as John Pork. So I'm going to use Leibniz principle, the substitutivity of identicals, which is a common second order pattern. If every predicate has the same truth value when applied to T and J, then T and J are identical. So let's first use that P ranges over all predicates. So this is a second order style premise. So we can write for all P, and then we're going to write the PT, and then you have the biconditional symbol, which means if and only if PJ. So we've now set up our kind of system. So for all values of P, we're basically saying that Tung Tung Sahur is if and only if is John Pork. So now if we take the for all elimination from for all P, let's do phi P, we infer, that's a terrible phi, we infer phi P naught for any predicate of P naught. So for any predicate of P naught. And now we need to eliminate, or do this, the biconditional if and only if elimination. So A if and only if B, and A infers B. We also now have an equality reflexivity. So this is actually something that you would do at university, which is these next two ones are going to be something in calculus. And sometimes when I first saw this, I just thought it was plainly stupid, but it's very important when you develop in calculus. So x for any term of x. So basically x is x. I'm not going to write that there, but x is for any term of x. And then we have equality equivity symmetry. So this basically means that A equals B and B equals A. So you can swap those around. So we instantiate, we're going to instantiate the second order quantifier with the predicate Px, defined as x equals t. So if we write this now formally, you're going to, written formally, this is going to be P, let's do a lambda equals x dot x equals t. So we've kind of got somewhere. So now, because we've laid out all the simple basics, we're now going to begin to set up our Fitch style proof. So it's Fitch style proof. So this is by laying out each of our conditions, numbering them, and then going, well, if one, then two, and so on. So we've got our first one, which is the premise. So we're basically supposing that Tung Tung Sahur is John Pork. So we're going to put that like this. I'll put that like that. So this here is the premise. So number two, we're saying if t equals t, if and only if j equals t. So from 1, by using this elimination, we instantiate, God, why can't I pronounce that? P with px. So we'll put p with px of x equals t. Now, for our third one, we're going to say t equals t. So we're now obviously saying that there's equality reflexivity here, so that's obvious. And then 4 is j equals t. Now this is where the leap happens. From 2 and 3, if and only if through the elimination. So we can only get this from 2 and 3 if and only if. So the biconditional elimination, A if and only if B, and A infers B. So we've now put that in here, we've got that. So now 5 means that if obviously we swap them around, they still equal the same thing, t equals j. So from 4, by symmetry, by equality symmetry, we're able to say that j equals t, and it infers t equal j. So in 2, we use the second order premise to assert that the predicate is equal to t and is true of t exactly when it is true of j. So that gives t equals t if and only if j equals t. So the reflexivity of our predicate 3 gives t equals t from the biconditional 2, and the fact that t equals t, we can conclude that obviously j equals t, and we assigned in the beginning that John Pork is Tung Tung Sahur, or vice versa, Tung Tung Sahur is John Pork. This is definitely the most meaningful piece of work, and probably Leibniz would be proud that what he's doing, or what he did, has resulted to this here. I know that this is very controversial, and I appreciate that the majority of the maths world is going to now come for me. I'm ready to defend this argument, and unless I'm shown alternative proof, I will not yield.